class, how are you all? Today again I'll continue with the chapter that is light, right? I have already given two videos. Now today I'll discuss with magnification the trick chart for the formation of image. In my previous video I already told this, and the mirror formula and sign convention. These are topics which we are going to discuss today, right? Now come. About the trick chart, suppose if I say that this is the concave mirror, am I right? Yes, concave mirror. So these are the positions of object. Previous video I already told you where the object is placed and the image is formed somewhere else. So it depends upon the position of object. Now if the position of object is infinity, it may be possibilities. These are possibilities that object could be placed, right? Now first the object is placed at infinity. Beyond center of curvature, anywhere you can keep, right? At center of curvature, this is third possibility. Between C and F, that is what? Center of curvature and focus. At focus, between focus and pole. Now these are the position of objects which I have mentioned here. At infinity, beyond center of curvature, at center of curvature, between C and F, at F, and between F and P. Yes, student? Now there is one trick. Yes, so that you can form the perfect image of concave mirror, right? Come. Now these are the arrows I have drawn here. Now here the arrow is closed and here this is again closed. Now what is the meaning of this? Now if the object is at infinity, then the image is at F. If the object is at F, the image is at infinity. Simple. Two ray diagram done. These are the closed arrows I have made here, right? At infinity, object at infinity. Where it is coming? At F. So, image is at F. If the object is at F, then image is at infinity. Simple. The second one, if the object is beyond C, then the image is between C and F. You can check in your NCERT book all the ray diagrams. Yes, that also I have covered all this. So, you can check whether actually it is forming or not. Yes, it is forming there only, right? So, if it is beyond center of curvature, then see, here the arrow is closed. That is between C and F, that means image is between C and F. If it is at what? Between C and F, then the image is beyond C. Yes, and if the object is at center of curvature, then the image is also at C. So, if you have come to know, but the positions accordingly you will write. These are the positions in the serial order, otherwise it will not. Clear? That is obviously from here 100% that the object we are going towards the mirror. Object is placed towards the mirror. So, one by one, same pattern you will arrange here, and this you can already do it yourself by knowing this trick. Yes, and first, highly diminished. At focus, highly diminished point size image. I have explained in that video. Next is diminished, same size. Now, highly diminished, diminished, same size. Enlarged, highly enlarged, and then enlarged. Now, what is this third one? That is between focus and pole. This is different. Why? That I told you, that is behind the mirror, the image is formed, which is virtual and erect. We have what? Dotted line I have used there to explain that. That is virtual and erect. So, the last case, this is the last case which is different, and 5 cases we can go with this trick. And the nature of these, real and inverted. And the last one is virtual and erect. Simple, just write it yourself once, permanent. Because definitely 2 marks ray diagram will come. Definitely it will come. Clear? Where? In your board only. Right? So this is the trick chart. And now next I am going to start with magnification. So what is magnification? Now magnify. Magnify means, what is that? To what? How when we are comparing with anything, suppose if any object is this much, it is magnified image this much. That means we are comparing the height of object or any image, yeah, height of any object, right? That is magnification, magnifying lens. You can see magnifying lens. So you can see bigger in that, right? Now here in mirror, what is magnification? It is the ratio of, very important, it is a ratio of height of an image to that of an height of an object. To that of height of an object. Means size of the object and what is the size of the image. Whether it is diminished, whether it is enlarged, whether it is highly enlarged, that means there is the difference between the object size and the image size. What is that ratio comes? That is known as magnification. What is magnification then? It is a ratio of height of an image to that of height of an object. In every ray diagram you have seen that the height of the object is different to that of the height of an object, except center of curvature where the size is same. Clear? So what is magnification? It is the ratio of height of an image to that of height of an object. So this is the formula comes, m is equal to hi upon ho is equal to v upon u. What is v? It is the position of image. U, it is the position of object. Clear? I'll explain you how you can trace the position of, means where object actually placed from the mirror. Then it is what? U, means position of an object. And where the image is formed, the distance from the mirror when we are talking about, that is the position of an image. Clear? I'll explain again. Now, this is the formula for is equal to is equal to. Any of the values will be there and you can easily trace. If the magnification is there and height is asked, so this is must be given in the numerical. Hi and ho will given and you have to identify m. So, you can easily, I'll take your numerical session, in that I'll show you all this kind of. If we have got and they have asked the height of an image, height of an image they are asking, you have got v, you have got u and you have got ho. So what this is again by crisscross method, that is in mathematics you all know. So if hi is this side, ho into minus v upon u. This is how we can interchange the formulas and we can what? Find in the numerical what is the requirement. If they are asking ho, height of the object, maybe they are asking height of an image, maybe they are asking position of object, maybe position of image or magnification. This is the formula which we can use there. Clear, student? Now, this is about magnification. They will, numerical they are going to ask of 3 marks. In that they may ask about magnification. Find the magnification. Next is mirror formula. Mirror formula means focal length, V and U. Explain you about what actually these abbreviations are for. Okay. Now come here. Now this is again I have drawn the concave mirror and this is the principal axis, this is the pole. Clear? Center of curvature, that is sphere. Center of any sphere is center of curvature and this is focus. Now if I am talking about from image, object. Now this is object and this is pole. If the object is the position of object, that is from the mirror, is represented by U. U is position of object. Clear? Write it along with me. Then it will be easier for you. Now what is V then? It is the position of, this is from the pole to this image. Suppose I have drawn beyond C, so it is between C and F. Suppose the image is formed there, right? So wherever the image is formed, this is the position from the mirror, from the pole. So it will be represented by V, that is small v. So V is position of image, U is position of object. Clear? Now this is focus. From here to the mirror, focus, that is the length of the focus from the mirror or from the pole is known as focal length, which is represented by small f. Capital F is focus, small f is focal length, that is length from focus to the mirror. Clear? Next come center of curvature to the mirror, it is radius. Yes, so radius, that is, this is center till mirror, this distance is known as radius. So R is equal, then what is capital F? Capital F is equal to R oblique 2. That is, half of the radius is focus. Half of the radius is focus. Okay. Now come, object is upright position. Upright. So this is known as height of an object. Yes, and image is inverted, so it is known as height of an image. HI. Downward, if it is height of an image, upward, height of an object. And we all know object is always placed upright. Object will never invert it. This is very, very important. Clear? Now next come sign convention. How will we give the sign? Sign means whether it is in positive side, whether it is in negative side, because in numerical they will give, suppose the position of object is 6 centimeter from the mirror and the images and the focal length is suppose 2 centimeter. So they are not giving negative or positive sign in front of the value. That means minus or plus 6 that you don't know. For that reason, the sign convention is used. Right? Very easy. See this trick. Suppose this is the concave mirror. This is what? V. That is from mirror to the object. This is U. Sorry, beta. This is object. And this is image. So position. This is the position I am talking about. Position of, yes, image from the mirror is V. So these are all I have arranged. Now what to do? If we draw one graph like this, very simple, this is the trick. And we know that mathematically in graph, the upper side is, that is the y-axis, positive, negative side. Right side, it is always positive side, and left side, it is negative. Clear? Mathematically I have done this. Clear? This is the trick to what? To know about the sign convention. Yes, now see, this is the mirror. This is the mirror. Center of curvature is towards left side. Focus is towards this side, that is left of your hand, and all are towards left side. Am I right? Yes. And this is upright, that is positive side, and image is, if it is inverted, I am talking about real and inverted, that means it is negative. Now, sign convention, very easy. Shall I start? You all will answer, right? Now, position of, yes, object, minus or plus? This side only? Yes, so it is negative. Image, position of image from the mirror. This is where? Negative side. So it is negative. Focal length, again from here to here, that is negative side. This is how, very easy, see nothing is there. Yes, you can automatically by doing this, simply a little bit, this diagram you can draw in your rough page and then you can do it like this. So numerical, which is of 3 or 5 marks, will absolutely correct. If you are not done about this process, that means you can't come to know whether it is negative and positive, and numerical is 100% wrong. So sign convention is very, very important part of the numerical. Because next session I will take you numerical. In that I will not tell you anything. I will just tell you whether it is left side or right side, positive or negative. That you yourself will tell me by doing this method. Okay? Now come. Height of the image. Now it is downward direction. See, position of image is negative, but height is downward direction. So what is this in graph? It is again negative. Height of object, upright position, positive. Very easy. Yes, student. And radius, it is again from here to here position is radius, which is again negative. These are known as exam. They can ask you about the sign convention question. What will be the sign convention of concave mirror for real and inverted image or for virtual and erect image? So nothing is there. You will just do it like this. Yes, this I have explained to you about real and inverted image. And remember, there is one case that is what? Virtual and erect, which is towards this side has been formed. Am I right with dotted? Yes. So now for virtual and erect. Yes, students, U will always negative because it is in front of the mirror. Simple. You can't keep the object behind the mirror. Nothing will happen then. Object is always negative because it is in front of the mirror, right? V. Again, now what is V? Position of image is this side. Yes, student, this is real and inverted towards left side. Now here for virtual and erect, positive. C. Correct? U. Now focal length, again negative. Left side. Because this side nothing is there except the what? Image formed. Right? All are negative towards. Now height of the image. Yes, virtual and erect, positive. Positive. And height of the object, positive. Radius, this side, negative. Done. Easy? Are you finding easy this? Now for convex mirror, we know that two images are there and the image formed is virtual and erect. Am I right, student? That is with the dotted line. First one is from infinity, that is point sized, can't be shown here. But second image was very important because there we can find the image like this. This is the image has been formed. In convex mirror I am talking about, student. Okay, now come. If I am talking about convex mirror, now this is this side. See, the sphere is towards right side and yes, student. Yes, positive, positive, negative, negative, positive towards right side and negative. Right? So, shall I start? Yes, student. Start. Now, where is image formed? Where is object kept? Object is always towards negative side. Between pole and infinity. So, this is negative. Image. Yes, student. Positive. Position is also positive and upright. That is virtual and erect. So, V is positive and height of the image is also positive. Height of the object, upright. That is positive. Focal length, this side. Why this side? Because sphere is this side. So, center of curvature is right side. So, focal length is also the right side. Right? So, F is positive. That means all are positive except object is negative in convex mirror. Now, this is the mirror formula. If I have come to know about all the sign convention, you have practiced well. Now, this is the formula we have to use when we will solve with the numerical. Okay? And now come. Now, focal length. 1 upon f is equal to 1 upon image distance. Right? This is image distance plus 1 upon object distance. Now, any one of the value you have to find and 2 will be given. Clear? Maybe focal length given or object given, you have to find the value of image formation. Image. What is the distance of the image? Where the image will form? And what is the real? Whether it is real or inverted or virtual erect, what is the nature? If the answer is coming in minus V, then real and inverted. If the answer is coming in positive, then it is upright, virtual and erect. So, when I'll go with the numerical session, there I'll explain you about where we can use. This is very, very important, student. Positive and negative, if it is clear to your mind, the crystal clear, then numerical 5 marks or 3 marks, full marks. Light is quite good chapter and it has good weightage in your board also. So, marking a little bit higher than other chapters. So, very important, and only 2 chapters in which you are having numerical. One is electricity. There you have to hold with the formulas. Here only 2 or 3 formulas are there. This is the one formula and the lens formula is there and the magnification. Clear? But this is very important. Yes, can it be possible now? I have tried my level best to explain you all by using tricks and trials. Clear? Okay, 10th class. Next session, I'll go with numericals. Don't miss. We'll go with numericals. I hope you all, by that time, practice this. Because that time I'll ask you whether it is positive or negative. Okay, student? Yes, 10th class. God bless you all. Thank you so much for, yes, cooperating me and giving me strength. Yes? So, please share, like and subscribe. Clear? Thank you so much, student. Thank you.